Te oyen bien.
So the next presentation is energy framework for TeraFlowSDN controller. So thank you, David.
Thank you.
Hello, I'm David de la Mostazo from Telefónica, and I'm going to present an energy framework for TeraFlowSDN controller. So basically, this framework is to collect energy information from the routers, analyze it, maybe create some metrics, and then have a visualization. So first, I'm going to talk about the structure of the energy framework itself. We have developed this outside TeraFlow in the first develop. So basically, it's composed with three different modules and three different databases. The first module, and probably the most important one, is the energy collector, and it's connected to the IP topology where all of the routers are there, and then it's going to obtain the energy information from the routers and then parse it into a giant data model that I'm going to explain later. And after that, it's going to save it into the first database that is a time series database like InfluxDB. And then we are going to create some kind of test. So that's where the analytics module comes into work, and the analytics is going to read the data from the time series database, collect all the data from the test, and then going to analyze it, obtaining some information like statistical information or static information. And it's going to save both of them into the other two databases, the analytics database and the static database. And then finally, on top of that, we have the web user interface that is going to read the data from all of the databases, especially the time series database and the static database. And it's going to show all of the information, have some kind of telemetry, and whatever we want. So first, we develop this into a Python project with some classes, with some models. And then after that, we try to first kind of simulate how TeraFlow works with microservices and Kubernetes. So we did it in our local machine. So, and then we are going to implement it into the TeraFlow structure. So basically, our model of analytics is going to be developed in the TeraFlow as the same as the energy collector. And we are, of course, using the web UI from TeraFlow. And then we have the databases. The new one, kind of new database, the telemetry, which will have the time series and telemetry database. And then we can use the context of TeraFlow to storage the static database. That's because the telemetry is going to be both of them time series database because we have a lot of data, but then the static database is going to be updated, constantly updated the data, so we can have kind of some like a SQL database or whatever. But I know that Ricard said in Monday that TeraFlow maybe is going to implement the database inside the modules, so we can do that, like having the database inside of Energy Collector and having the database inside of the analytics. So first, I'm going to get deep into the modules. The first one, the Energy Collector, of course, is going to obtain the energy information. How is going to do it? With these different methods. The first one is using the command line interface of the routers. This is really simple. We have the router, we can connect to the command line interface and obtain all type of the information. This is the best way, the easiest one. And so we have some commands, we obtain the power information. And the most important thing is that we're not only going to obtain the whole router power information, but also if it's possible, we can obtain the difference consumption from different parts of the router, like CPU, boards, or whatever. And this is important because in the next one, the smart power strip, we have smart power strip in our lab, so we connect the routers to it. It's just a rack PDU, so each router is connected to one socket, and we can obtain the power consumption of each socket. So this is not differentiating between types of power or components or whatever, it is the whole router. And then this is also important because this is the more reliable one. This is 100% what the router is consuming. Instead, like in the command line interface, maybe we can have some kind of 5%, 10% of difference between the two of them. So we can try to use both of them. And then the third one is using netconf with some standard models with OpenConfig but for now we are not going to use it. We have been discarded because it's not well implemented in all of them vendors, so we're having some problems. So with that, we are going to use the two, this command line interface and the mark forward strip. And what's the problem? That we have so many different types of information, so we need to parse it into the same YAN data model. So I put it here some examples. In the smart power strip is going to be the same for all of the routers or the devices, and if it's a computer, it's going to have the same structure. So we have no problem here. But then in the command line interface, each router give us the information is in our way. So we have to kind of put it all together into the same model. So to be able to compare all of them, to save it into database. So we created instantaneous DAN data model. This is for now for the instantaneous data. So we are obtaining the information each 5 seconds, 1 second, whatever, and we are going to parse it into this model. There are some other efforts in the ITF or OpenConfig to have like a standardized model, but for now we are going to use our own one. So this is really simple. We have the container device with the device that we are using, and then we have the power consumption of the router itself with the power, maybe some kind of energy model, energy efficiency, whatever. But this power consumption is not always the same. It depends on some characteristics of the configuration, the metrics of the traffic or whatever. So we put it like having the configuration. We need to know what's the configuration of the router, how many boards it has, how many transceivers they are connected, and then some kind of performance metrics like traffic throughput, traffic packet size, or some kind of the temperature or whatever. And then with that, we obtain the information of the power consumption of the router as a whole, as a router, with why this router is consuming that energy from that power consumption. And then we have divided it into the components of the router. Of course, the router can have one power supply, maybe two or more of them. And then we have the different elements of the router, different components like CPU, fans, or whatever. And then we have the boards and the transceivers. So all of them with the type and the power. And then the second modules come to action. So we have the analytics. Analytics works kind of in two ways. The first one is doing tests. So we put a test to be done, and when we have a total time. So it starts and then it ends. So we have different test parameters. We can decide which devices we are going to test, the time of the test, the length of the test, and put some traffic throughput and how this traffic throughput and packet size are going to change during the test. And then we have another one, too, that is basically a telemetry, a real-time device per energy consumption. So we obtain the power consumption of all of the routers and display it. And this is also interesting because we can create some kind of warning if we know how is the minimum power consumption of the router and the maximum, we can have kind of a warning for low or high consumption. So basically, I'm going to talk now about the test one. So after the test is done, with maybe 1 hour, maybe 9 hours, it doesn't matter, the analytics start to work. So it's going to check, it's going to obtain all of the information from the router, all of the instantaneous information that I showed you before from the database, and then it's going to analyze it. Analyze it, checking the intervals where the traffic throughput, packet size, and configuration has been the same. So we have maybe a sample size of 100 in that interval. So we have some statistical information like the average, of course. And with that, we obtain the telemetry data for the test and save it into the database. And with that, we created another YAN data model that is for static data. Static data is data that is basically never going to change. We save in a database and we know how much is consuming for the state. So with the information of telemetry, we know that if the router have some kind of a configuration, a specific configuration, a specific traffic size, a specific packet size, or whatever, we can obtain the static data. So that's what the analytics is going to do, and then it's going to save it into the database. So the static data YAN data model, it's kind of the same as the instantaneous, but this one is going to be updated in the database. So we have, again, the device with the typical power consumption of the device, maximum traffic, maximum power, efficiency, whatever, and then also divided into the elements, the power supplies, the boards, the components, and all of the information. And so with that, the last module is the web UI, simple web user interface. So in this case, we created outside TeraFlow, and then we are going to integrate it in the TeraFlowSDN web user interface. So this is divided from kind of four modules. The left top is going to be the one that create the test. So basically, we select which routers we want to have the test, the time of the test, the total time, packet, how is the traffic going to change, and whatever, and we just run the run test, and it starts. It starts with a log in the left bottom, and it's going to show how much the routers are consuming. If we have one router, only one router, but maybe we have four of them. And then in the top right, we have kind of a topology. We can check the topology from TeraFlow and display it. And so if we check how much those routers are consuming, we can put it in the topology. So we have some kind of real-time topology energy consumption from the routers. And then last one, in the bottom right, we have the static data. So we select which router we want to obtain the static data, and it's going to consult the database and display it here. And so with this framework, we did some use cases. The first one is the most obvious one, the right one, the router power consumption. So we created some graphs to know how much the routers are consuming, depending especially with the traffic. And then another thing is that we created a router energy consumption model. We call it like that. So we don't only want to know how much the router is consuming, but also how is it consuming. So is it consuming more in the chassis, in the boards, depending on the traffic. So we created some kind of a formula with the data that we try to learn about it, and then create this formula, divide it into the idle power, the traffic power, and so we have a paper about all of this. And then the new use cases, the one that we are working right now, is called dynamic multi-layer topology configuration for energy optimization. So we are going to change the topology, the IP topology, depending on the traffic, especially daytime and nighttime. And then we can have some kind of energy optimization. For example, if we change from a star topology in the daytime to a horseshoe topology in the nighttime, we can save some ports, some boards, so we know how much those boards are consuming, and we are trying to optimize the energy consumption. And then in future work, obviously, we are going to implement this into TeraFlow. For now, we are only have it in our local machine with a Kubernetes cluster. So we are trying to implement it into the TeraFlow. So TeraFlow with the web UI and everything can use this framework with the modules, the databases, and the web UI. And then utilize it into other use cases, like the one I told you before, maybe some kind of green slices to have slices depending on the energy consumption, and more use cases that we will work in the future. So we have done this in Telefónica and in the Allegro project. So that's all. Thank you.
Okay, just one quick question, curiosity. Have you been discussing this with aligning with the architecture of monitoring in TeraFlow with the VS and the tech team?
No, for now, we have been not talking with TeraFlow, but
okay.
Yeah,
because it might be of interest to align, and it would be good that in the next weeks you showing some text flow and you discuss it because it might affect some components. So it's important to align.
Okay, we will. Yeah.
So thanks a lot.
Thank you.